Hi, welcome to the next assembly video for the RepRap Prusa Mendel Iteration 2. In this video we're going to install all the software we need to connect to the RAMPS 1.4 electronics so that we can move on to calibration and then eventually start printing. Okay, so first I just wanted to go ahead and show you that if you go to reprap.org/wiki/ capital RAMPS_1.4, you can review the electronics page at the RepRap wiki. Describes the assembly process for the board itself and has some other information. And when you connect all of your electronics to the ramps, all of your components to the electronics, you will need to follow this diagram here. And if you click on it, it'll enlarge, and click on it again, it'll enlarge even further. And so it shows you exactly where to hook up the thermistor for the heat bed, where to hook up the different stepper motors and the power supply and everything like that. So just follow these instructions here. Okay, now let's go ahead and start by downloading all of the software that we're going to need. So go ahead and open up an internet browser window and then go to google.com and then search for Arduino. And the first hit here is the Arduino homepage, which is perfect, arduino.cc. Let's go ahead and click on that, and then click on the download link at the top of the page. And we're going to scroll down to the previous IDE versions, and we're going to download the Arduino 0023 for Windows. So I'm going to go ahead and save this to the desktop. And let's go back to Google. We're not going to install that yet. We're just going to download it for now. We'll come back and install it later. The next program we're going to need is the firmware for the electronics. So in this case, we're going to use the Sprinter firmware. Let's go ahead and search for Sprinter firmware. And the first hit here is the Climate Sprinter at the GitHub. That's perfect. Climate is the author of the Sprinter software, so we're going to go ahead and download that. So click on the downloads link on the right side of the page here, and then click the download a zip, and let's go ahead and download that to the desktop. Now you can use other firmware for the RAMPS 1.4, Marlin for example, which works really well, and you're free to download that and give that a try. But if you're going to follow along in the video, it might be easier just to use Sprinter for now. Maybe you could try Marlin later. Okay, so go ahead and go back to Google. And the next program that we're going to need is called Pronterface. Just going to type in Pronterface. And again, it's going to be the first hit here by Climate at the GitHub. And instead of going to downloads, we're going to scroll down to the README file. And there's a link in here for the pre-compiled version. So let's go ahead and click on that link. And there's two options here, the Windows version and the Mac version. So I'm going to download the Windows version and save it to the desktop. You know, you're free to use the Python version, but in order to use Python, you will have to install Python, and there's a few extra steps there. So for simplicity's sake for the video, we're just going to use the Windows version for now. But if you always want to maintain the latest version of Pronterface, then you might want to download the source version, which is in Python. Okay. And the next program we're going to need is a program called Slicer, spelled with a 3. And again, this is going to be the first hit here, slicer.org. And looks like the 0.9.7 is out, so let's go ahead and download that one for Windows. And you can either download it for a 64-bit operating system or a 32-bit operating system. I'm going to go ahead and download the 32-bit version and save that to the desktop. Okay, that's all the software we need, but let's go ahead and download a file that we can use for calibration and for our first print. So let's go to Thingiverse and search for 20mm cube. And I happen to know it's on the third page here, so there it is. 20mm cube by Engine Glue. I happen to know that this is a perfect 20 millimeter cube, so I'm going to go ahead and download the STL file here, save it to the desktop, and we'll be using that a little bit later. Okay, so that takes care of all the software that we need. So let's go ahead and move on to the installation here. So first we'll need to extract the Arduino software. So go ahead and open up the Arduino zip file and extract that to the desktop. Okay, that's going to take a little while. While that's extracting, let's go ahead and extract the Sprinter software. So I'm just going to extract that to the desktop. Okay, and let's go ahead and extract the Pronterface to the desktop. That's in the distribution folder there. Okay, I'm going to go ahead and rename this so I don't forget what this is. Oh, whoops. Okay, and let's go ahead and extract the slicer program. Perfect. All right. Okay, that finished extracting. Now, next, we need to make sure that the driver is installed for the Arduino Mega. So go ahead and open up your control panel. Start Control Panel, System, Device Manager under System. And I can see here that this is for something else, but this is the unknown device that's showing up for my ramps for the Arduino Mega 2560. Sometimes it'll install automatically, sometimes it won't. So to install the driver, right click on it and click Update Driver Software, and then click Browse. And then browse to the drivers directory under the Arduino software. So I put that on my desktop and just click on drivers and click OK. This will ask if I want to install. So go ahead and agree. There we go, Arduino Mega. And that installs the software, so now it's ready to go and it's on COM3. Okay, so now go ahead and open up your Arduino software program. And let's make this a little bit bigger. And then click on File, Open, and then navigate to the desktop, to the Sprinter directory, Sprinter, and then open the Sprinter PDE file. Go ahead and close the previous window. And then click on the Configuration H file. The first thing we'll need to do is make sure that the motherboard is set to 33, which is for the ramps 1.4, as shown here. It's usually set to 33 by default. And then you'll want to scroll through and just make sure that all the other settings are correct. We'll be coming back to this later during the calibration video to adjust these axis step per unit values. Now, if it's not already, go ahead and change the baud rate to 250,000, and you just comment it out and comment out the baud rate 115 and then switch it to the 250,000. So SD support is on, and then you can also turn on the SD initialization file. Then just scroll through and see if there's anything else that you need to change. You might need to invert the axes later. You could adjust the max distance that the axes can travel. And now, all of these settings are detailed in here with notes, but you can also go to the README file at the GitHub, or just search online for the ramps 1.4 settings, and you can get more information on what all these settings do. And then also you can go to the RepRap chat room on the IRC. There's lots of really helpful people there who can help you with these settings too if you have any questions or problems. You could adjust the max temp if you wanted to. And that looks good. So I'm going to go ahead and save this. Now I already have the ramps connected to the USB cable on the computer. So I just need to go to Tools and make sure that the board is set to the Arduino Mega 2560. And then also just make sure that the serial port is set to the right serial port. In this case, for me, it's COM3. That's checked. And now I can go ahead and burn this to the electronics. To do that, just click on File and click Upload to I/O board. Okay. And down here at the bottom, it'll tell you the status. It says it's uploading to the I/O board. Okay, it's done uploading. So we can go ahead and minimize this program. And now we can open up Pronterface. So go ahead and open that. And just set the COM to COM3 or whatever your COM port is for your printer. Change the baud rate to the 250,000 that we changed in the settings. And then click Connect, and that should connect to the printer. There we go, it's connected. And now I can go ahead and test it out. So I can try moving the x-axis a little. Or the y-axis. Or the z-axis. Well, it's looking pretty good here. So I am connected, and to use this program, again, there's help online, but it's pretty self-explanatory. This manually moves your axes, and you can turn the hot end on. You can turn the bed on or off with these set buttons here, or off buttons. You can operate the extruder, which is helpful if you want to feed filament in, and this can also print files. So after the calibration videos, which are coming up next, you'll be able to click on Load File and browse to an STL file, and then you'll be able to print. So very, very useful program. So that looks good. I'm going to go ahead and disconnect, and I'll talk about calibration later before we can start printing. One more program I'd like to show you is the slicer program. So let's go ahead and open that up. This is where you'll convert 3D models to G-code so that the printer can understand it. So the way this works is you can just drag and drop a file into the program, and it'll show you sort of a preview of where it'll be printed on the bed. And you'll want to go through and change all of these settings to match your printer. For example, you may want the layer height set to 0.3 millimeters. And later on in the calibration, we might find that the first layer height needs to be modified. You can adjust the infill percentage and other settings, the speed of the axes, support material, and under filament, you'll want to measure the actual width of the filament. If you're using 3 millimeter filament, it might actually turn out to be 2.8 millimeters. So you'll want to change that here. This is also where you'll set your extruder and heat bed temperatures. And if you have a fan connected, you can turn that on here. And under printer, you can offset your center if you need to. And you can add custom G-code. And under the extruder 1 settings, you'll need to set the nozzle diameter. In my case, I'm using a 0.5 millimeter nozzle. And you can also adjust the retraction settings and other settings here. So everything looks good for me. So if I wanted to, I could export the G-code file here, and I could just save that to the desktop. And then in Pronterface, what you would do is you would load the file. the 20 millimeter cube G-code file, and then you can print it. And if you want to preview what it's going to print, you can click on it here in the preview, and you can hold down the shift key, use your scroll wheel to see what it would look like, what each layer would look like. Okay, but we're not going to print anything yet because we need to do calibration, and those are going to be in the next videos. So, thanks a lot for watching.